Hello, this is Dr. Rody, and in this video, I'm going to show how to use Excel 2010 to perform the calculations necessary for a chi-square test of independence. In this example, it asks us to use the data below to determine if there's evidence to suggest that burglary clearance rates are not independent of whether a neighborhood is predominantly minority or predominantly white neighborhood. So I have some data here in a two-way table that shows whether the burglary was cleared, in other words, solved, or whether it's still open or unsolved. And then it's also categorized by whether it's a minority neighborhood or a predominantly white neighborhood. And we want to figure out, is the fact that a case is cleared or open related at all to whether the neighborhood is minority or white? So the null hypothesis here could be stated in terms of independence or in terms of the relationship. And it really depends on the problem and the context. They generally mean the same thing. It's just a matter of what language you use depending on how the problem is presented to you. So in this case, the null hypothesis would be that the burglary clearance rate is independent of whether a neighborhood is predominantly minority or predominantly white. And the alternative hypothesis would be that the burglary clearance rates are not independent of whether a neighborhood is predominantly minority or predominantly white. Another way of stating that is that there is no relationship between whether a neighborhood is predominantly minority and white and the burglary clearance rate for the null hypothesis, and the alternative would be that there is a relationship between those two factors. Okay, so let's get down to the calculations. Again, our first thing we really need to do is figure out these expected counts, then use the formula to find the chi-square test statistic, and then find our p-value. Well, the first thing I'm going to need are the marginal totals in this two-way table. And the data that you're given in the problem, sometimes it gives you these totals, sometimes it doesn't. Sometimes you get the data in a table like this, sometimes it's in the text of the problem. But it's usually up to you to figure out these totals. Well, this isn't too difficult. I can just highlight that cell there, use the summation command, and just double check though that it's highlighting what you want to total. And yes, I want to total across there. Then I want to come here and do the same thing. Do the same thing here. Always double checking that it's the right range that you want totaled. You could also copy these formulas, whatever you feel like doing. And then also I want to find out my grand total. So I'm going to go ahead and find my grand total. That would be this coming down or across. It should come out the same. And sure enough, 17 plus 13 is 30. 15 plus 15 is 30. So this is my grand total. So I want to figure out in the expected counts what these cell values would be. Under the null hypothesis, in other words, if there's no relationship between the neighborhood, whether it's minority or white, or the clearance rate of the burglaries, what would we expect these counts to be based on the total of 30 and how these values related to each other? Well, the formula to find the expected counts is to take for each cell, so let's look at cleared minority, to take for each cell the row total times the column total, to take that product and divide by the grand total. Well, the row total for cleared is 17. The column total for minority is 15. So I would take 17 times 15, and then I would divide that by the grand total of 30. So I'm going to go in here, and I'm just going to do each one. I'm going to program each cell manually. I'm not going to try to get fancy with cell references and all. There's only 4 cells. Even if you have 3 categories each, that's 9. It's not too many to do. If you're really skilled and you know how to use anchoring, you can do cell references. I'm just going to do each one one at a time. Now you can actually type the numbers. I could just do the 17 times 15 divided by 30, or I can point at the numbers. It's really up to you. times. I don't really have to use those parentheses. The order of operations, I could have left that out. So I get 8.5. So now for this one, equals, and again, I could notice I can just leave off the parentheses actually. 13 times 15 divide by 30. Enter. Do the same for here. And again, if you want to, instead of using the cell references, you can just type the numbers in as you see them in the table above. I'll do the next one like that just so you can see. So instead of referencing the cell, I can just say equals. Well, the row total for open is 13 times the column total for white neighborhood is 15. Divide by the grand total is 30. It's really whatever you find to be easiest to do. Okay, so let's check our totals. Yeah, 15. These marginal totals should come out the same. So it's just a good check to make sure you did your calculations right. And sure enough, they all came out the same. So now knowing that these marginal totals are the same, I can be fairly confident that I did this okay. So now what I want to do is calculate the chi-squared test statistic. And that will be according to this formula. For each corresponding cell, do the observed minus expected squared divided by expected. The degrees of freedom of my chi-squared test statistic will be the number of rows minus 1 times the number of columns minus 1. So in this case, I have 2 rows and 2 columns, so that will be 1 times 1. So my degrees of freedom will be 1. So let's get down to the business of computing our chi-squared test statistic. I want to do equals, parentheses, minority cleared observed, that's 5, minus minority cleared expected, that's this number right there, the 8.5. I'm going to close parenthesis, caret for exponential, squared, divide by, and then do the minority cleared expected value again. So this will be the value that for this particular cell for the chi-square test statistic. I'm going to do the same calculation for each one. I want to do observed minority open minus expected minority open, square that, divide by expected minority open. And do this through each cell in the chi-squared table here. White open, observed, minus white open expected, squared. And it's always a good idea to go through and just double check it all. All right, let's look at our totals. Use the summation key as a shortcut to find these totals. So our grand total here is 6.651584. This is our chi-square test statistic with degrees of freedom 1. So the next step is to find the p-value. Well, I'm going to use the chi-square test function equals chi sq test right here. Returns the test of independence for the chi-squared value. So I'm going to do this, double click, and then it wants us to highlight the actual range. So I'm going to go to my actual or observed. I only want to highlight the data in the cells. I don't want to do the marginal totals or the labels, comma. Then my expected, close parenthesis, hit enter. So my p-value is 0.009907. Well, in this case, they didn't suggest a level of significance, so I'm just going to use the default of 5% or 0.05. My p-value of 0.009907 is less than 0.05, so I'll reject the null hypothesis. There is evidence to suggest that burglary clearance rates are not independent of whether a neighborhood is predominantly minority or predominantly white. Or you could say that there is statistically significant evidence to suggest that a relationship exists between whether a neighborhood is predominantly minority or white and whether the burglary has been cleared or is open. I should say there is statistically significant evidence to suggest that a relationship exists whether a neighborhood is predominantly minority or white and the burglary clearance rates in those neighborhoods.